Here, this,
Hello. Hello, everyone. My name is Vivian and I'm from a startup company called Second State, and we are building a cloud-native WebAssembly runtime. Today, I will share about how to build a Rust application with one single Wasm manual. That's one of the main advantages of Wasm. It's portable. It's cross-platform. So before I start, I also organized the Rust ChinaConf, and this year's Rust ChinaConf will be happen on September, and the CRP will be open today. And I hope if you are interested, and you can submit a CRP. And the location is Shanghai. So before I do the demo, I want to make a short explanation about what is a RAG. RAG is retrieval augmented generation. It means that we will add some external knowledge to the language model. So to build a RAG application, first of all, we should create the embeddings for our knowledge base. So this is the workflow for building the embeddings in the vector DB. So first, you will have your own knowledge base. It may be some documentations, or it may be some notes. And then you will need to chunk your knowledge base, which means that you segment your text into small paragraphs. You can do it manually, or you can use some options. And then we will use an embedding model to convert your chunks to the embeddings. And then we will index the embeddings into the vector DB. So when a user asks a question, the application can retrieve and search the embeddings in the vector DB. This is how we make our normal knowledge into embeddings. When we have embeddings, we can make our RAG work. This is the workflow for the RAG application. So if you ask ChatGPT-4 a question, the ChatGPT-4 will answer your question with its own knowledge. But in the RAG application, when you ask a question, the embedding model will firstly convert your questions into embeddings, and then the embedding models will go to the vector DB and search all the similar embeddings based on your questions. And when the embedding model searches all the similar embeddings, it will convert the similar embeddings to the chat model. And the chat model will use the embeddings and the user question as context. And then the chat model will answer your question. Before I continue, is there any question here?
Yes. So what is the input token for the LLM?
Oh.
Is it the original question you wrote, or the context you get from the database?
Do you hear?
What is the input of LLM? For example, for a traditional LLM, you just input a several tokens to the model, and then it will auto-regressive generate the new token one by one.
I will demo later so you can more understand. Let's see a demo.
Oh, okay.
So, okay, the demo time, I will build a RAG application on my own computer. It's a MacBook Air. So the demo will use the Gaianet tool. It's based on the Wasm runtime, and the RAG application function is written in Rust. So. So the first step, we will install some softwares. I will use this command line to install. Wait a minute. We will install the Gaianet CL2, and we will also install the Watermelon runtime. It's the LM runtime. It means sometimes if you have your computer, you can follow me. We are installing Watermelon runtime and its GGM plugin here.
I see your profile, you're involved in second state and also Wisdom HIO. So could you maybe tell us a bit about the background?
Oh, yeah. I work for the second state company. It's a startup company, and the main product of this company is Watermelon runtime. It's called native Web3 runtime, and it's a CNCF sandbox project. So my role here is acting as a product manager and the community manager. So we have installed the Watermelon runtime, and we will also install the QGrant vector DB. The QGrant vector DB is also written in Rust. Now we are downloading the Rug API server.wasm file. It's the Rug application. It's written in Rust, but we compiled it into Wasm.
Let's run by
Possible
it.
there.
Let's cut.
Okay. I think it's almost done.
Yes, sir.
Yeah, it's almost done. So use this command line. We will install the Watermelon runtime. We will install the QGrant WebDB, and we also will download the Rug API server.wasm binary. And we will also download a web UI so we can check it via the web UI. And Then we can use the Gaianet. We will use the Gaianet init to download the models that we need. Llama 3 8 billion is the chat model we will use, and the nomic embedded text is the embedded model we will use. And now we will recover the QDrone snapshot. The QDrone detection snapshot here is a Paris guide. And it's time, then we will. This is a command line to init to run the RAG application. It's very long, so that's why we have a CL2 here. And I think our RAG application is running. The Gaianet CL2 includes FRPC tool, so we will have a link, HTTPS link to allow others to access our RAG application. So we can ask a question to the RAG application. Sorry, my network is.
Yeah, I think you want to try the networking. Then you download the LLM model using your data.
Okay, so we can ask a question about Paris. Then we can see what will convert to the chat model. So let me ask a simple question. It's very slow. I don't know why. Let me check the log.
Excuse me. What is an HTTPS server? Is that a proxy? Is that routing back to your local? Or?
Yes, it's a proxy.
You cannot go directly to your local without the proxy?
Oh, I can.
Okay.
The local is localhost is it.
Okay.
So if you carry your data, you can write locally. If you want to other people access your web service, you can send the link to them.
Okay.
But I don't know why it didn't work.
Okay.
I'm sorry.
I see.
Let me try again.
different to Olama? In terms of performance, do you have like default
Oh.
of Revism and
Yes, it's similar to Olama. Both Olama and Automatic provide an OpenAI compatible API server for the open source large language model. But Olama only can do general chat. But we going forward we build a RAG application server. So you can use this version file not only to do the OpenAI compatible API server, but you also will have a RAG application. That's the difference. So let me check if it works. Okay, it works. Because my computer is only 16 gigabytes, it's very low end.
is the M1?
Yes, it's M2.
M2.
But it is. So from the log, we can see what the RAG application do. So first, the embedding model will compute the compute embeddings for my inquiry. Is where is the Paris, and the embedding model is nomic embed text, and then it will search all the similar embeddings. You can see that it searched those texts, and then it will merge the RAG context. It will put all the context that the embedding model searched into the system prompt, and then the chat model will answer my query with about context. So you can see it will use the whole the search context and the question, the user's question to answer my question. That's how it works. So I don't know whether it's answer a question.
So the whole bunch of search output will be feed into the input of LLM.
Yes. So that's that is my my demo. If you want to try, you can just go to the let me see, where is it? Go to this document this website, and you can follow my this is what I did what I just did. And also, if you want to build your own knowledge base, the Gaianet also provides some ways for you to build your own knowledge base. The demo I just use is a Paris guide. You can build your own. So go back to my talk. So this is the architecture. The bottom layer is that the device. You can run it on GPU, you can run it on CPU, and other device. And about the hardware is what I runtime. It is LM runtime. And then we will have the chat model and the embedding model. And after about that, we will have the vector DB, and we will have our knowledge-based embeddings in the vector DB. And before that, we will have the RAG application server to handle the whole process. So that's how that's the architecture. And in my demo, I use the what's my runtime and the LM runtime. I also use the Qdrums vector DB to store my embeddings. And I also use my RAG application is written in Rust. And I use the embedding model Nomic Embed version 1.5. And the chat model is Llama 3 8 billion. You can use any open source chat model. So when we need Rust and Wasm in large language model, because it's high performance, I think I don't need to explain more. And because of Wasm, we can write it once and run it everywhere. The RAG API server Wasm binary is portable. You can build it on your MacBook and then run it on your NVIDIA GPU without any changes. And the third one is that it's very lightweight. There is no Python dependency. And the last one is that the vector DB Qdrums written in Rust is scalable, and the Wasm itself is container ready too, and you can manage your RAG application using Kubernetes. So that's why. And here are the resources that I use today. The first one is the Gaianet GitHub repo, and you can see the source code, check out their source code, and the Gaianet docs, which I just showed you, and also the Wasm runtime, and also the Llama. Llama is the LM developer platform based on Wasm. And the two images is that we have some open source developer programs. One is OSPP. It's called Open Source Pro. Oh, sorry, I don't know the full name, but it recruits some students, and the students can contribute to the open source project, and the students will get some money, get some salary for contributing to open source projects. So one is the OSPP, and the other one is LFX mentorship. LFX mentorship is organized by by the Linux Foundation, and the OSPP is organized by OpenEULA. So we have 4 talks that all of them are LM related. So if you are interested, you can apply, and you can receive some money for your work. So that's all. Thank you.